Now let us do this second problem. Let's read it out. A coin of mass 10 gram is placed at a distance 10 centimeter from the center of a turntable of radius 1 meter. It just starts slipping when the speed reaches 90 rpm. Calculate the coefficient of static friction between the coin and the turntable surface. So now let us make a sketch. This is the turntable, this is its center, and this is the radius of the turntable. My coin is kept here, okay, and this distance, the center is O, and distance of this coin from the center, that is about 10 centimeter. Now there is one point here. Radius of turntable, does it make any difference here? It is not going to do any difference. So there is no point in calling this R. Then what is the radius of circular motion? Radius of circular motion is going to be the distance of this coin from the center of this turntable. So my R, radius of circular motion, is going to be equal to 10 centimeter, which is equal to 10 upon 100. So this is 0.1 meter. So that is number one. What about mass of this coin? Does it going to affect the circular motion, or whatever we are going to calculate over here? Let us write it here, let us mention it here. Mass is equal to 10 gram, that is equal to 10 into 10 raised to power minus 3 kg. We'll take it if required. Okay. Now they say it starts just slipping when the speed reaches 90 rpm. Now speed is equal to 90 rpm, so that is 90 revolutions per minute. So every second, so we are going to divide by 60. So 90 upon 60 revolutions per second. So we can call this as frequency of rotation. It completes 90 revolutions in 1 second. 90 revolutions in 1 minute, that is 90 upon 60, that is 3 by 2 rps. 1.5 revolutions in a second. Can we calculate the angular velocity here? We can. So angular velocity is equal to it would be 2 pi into number of revolutions per second. So that would be 3 upon 2, that is equal to 3 pi radian per second. So in 1 second it is making 3 pi. See, in one revolution it is 2 pi, and in the next half it is going to be equal to pi. So it is total is going to be 3 pi radian in 1 second. Now we have omega, we have the radius of the circular radius of circular motion, we have that, and they say it starts slipping at this speed. So what does this mean? This means that, see, when this coin is placed here, the coefficient of friction is mu, and what is going to be the frictional force of friction? See, as long as force of friction is equal to centripetal force, it will remain there. But the moment your centripetal force starts exceeding the limiting force of static friction, it is going to slip. So we are just taking the limiting condition. Force of friction is equal to m omega square r. We are just going to equate that. And what is force of friction? Force of friction is mu times the normal reaction. So mu times mg is equal to m omega square r. So m I'm going to cancel on both sides. So this m which is given, it is not required. So it is extra data. So what we can do here is mu is equal to omega square r upon g, and that is equal to 3 pi. So 9 pi square into my r is equal to 0.1 meter, and that divided by 9.81, that is the value of acceleration due to gravity, and then this is going to be equal to 0.9 pi square divided by 9.81. Now this pi square is going to be equal to, approximately it is going to be equal to 10, because it is 3.142 squared, right? What is square root of 10? Square root of 10 is 3.1612, 3.162, something like that. So square of pi is going to be somewhere near 10. So 10 into 0.9, that is 9, and 9 upon 9.81. So your answer should be somewhere about 0.9 or it would be 0.1, somewhere on that. Okay, so this can be calculated using your calculators. In the next video we are going to tackle one even more interesting problem. Thank you so much.